now that we have everything set up within the standalone version, we now go into LIGHTwave, and I have a scene loaded in, castle scene. It's really just a castle object within the scene setup to be controlled by a null object for the different parts. So the different towers and walls being controlled by a null object, which I have set under the object properties to item shape on the null set to a grid at around 20 meters. So currently nothing really special set up for this. Taking a look at the render. Go ahead and render that a little larger so you can see the full-size scene. So just a basic distant light setup. And I'm using a perspective camera. So just a very basic scene. So let's go over to the xStream menu. Also keeping in mind that mine is slightly customized. So some of these options up here are not directly available unless you create your own customization. Usually it's a good idea to have some of these commands very easy to access. So let's first take a look by going to the Options panel. And once we select any of the commands, it's going to load the plugin, because by default the plugin itself is not actually loaded in to the scene until we add something to it. So I'm going to go ahead and click on Options. And after the splash screen shows up, we'll be able to see the xStream options. Now, there's a couple of different ways to work with Vue. You can either take your Vue scenes and Vue scene file and save it with the LWS file by incorporating the Vue scene. I do not suggest this. If the Vue file becomes corrupt, it will corrupt any file that it is incorporated with. So if you were saving your LIGHTwave scene, and even if you had a bunch of different copies, if the Vue scene itself remained the same, it's going to corrupt all of those files. So it's a good idea to leave that off and save your Vue scene separately. Typically a good way to work. We can also set a relative to the LIGHTwave content folder. So depending on the way your content is set up for a specific project, or just if you have an overall directory that you use for everything, you can set up your scene files that way. Taking a look at the scale, by default we have it set to the automatic mode. And if the Vue internal unit or the Vue unit of 1 is equal to 1 meter, as we had set it up in the standalone version, then you're typically going to have a really good match between the two applications. The only problems come in when modifying certain objects and working with ecosystems, and in some cases it can require some very small units. There's also some problems when it comes to dynamics because of the scale of the scene, and we'll see that in just a second. The light options match Vue sun with existing native sun object. What this should do is create basically a sun object to match the current distant light. It's not necessarily going to work. We'll have to see. If the Vue plugin's already loaded in, and then you create a new scene, it typically does work out just by not even using the default LIGHTwave distant light that's included in most clear scenes. We're going to take a look at the light conversion a little bit later. Right now, just taking a look at the geometry quality. There's two different options, low and high. High is usually pretty good. Low isn't really all that required. It mostly will affect the way terrains are created and high geometry plans. We can also set a limited number of ecosystem instance proxies. So I'm going to go ahead and add something to our scene. Make it a little more interesting. We can see some of these different options. Also go over to the render options. And we do have the ability to use ray marching evaluation. This is primarily for incorporating multiple volumetrics. And Vue is a volumetric plugin. So if you're going to be rendering with hypervoxels or any other volumetric, it's a good idea to turn that on. And then we'll also take a look at the render qualities in a little bit. So now that I've set this to be non-incorporated, once closing out the panel, it is going to ask to save the Vue scene. So we need to choose our location where we're going to be saving it. By default, it is going to go to the installation content directory where you chose to install your Vue content. Now, I have a separate hard drive set up for all of my content, and it is usually a very good way to work to have your content directory be on a separate hard drive than your operating system. Provides much better response between rendering, accessing RAM, and everything. So what I do when I install Vue is setting up having a separate folder separated from basically everything else, not using the installation folders, and I typically don't save anything within these folders. These are just the installed content. That way, if you update the program or remove it, uninstall it, you don't risk losing any of your files. So I actually use a different content directory to store all of my objects, images, and scenes than the installation directory, but still on a separate hard drive. The only exception is metanodes, which can be accessed directly within the interface if you put them in the content directory. So of course, having a separate copy for that is useful. So this is my LIghtwave content directory, just to had all of the different folders generated automatically from the menu option. I'm just going to set up a folder for Vue scenes, and then we're going to create our file for the Vue scene. So I'm going to call this Castle Environment. I'm also going to choose to turn off the Incorporate Texture Maps. If we're using any of the content included with the program, let's say we have a bunch of plants in our scene, it's going to save all of the texture maps within the file, which we can just access the content for those files and save a lot of system resources. When it comes to network rendering on the final output, then it's a good idea to incorporate the texture maps. But while you're just starting with the scene, it's usually not required. So now the scene is loaded in, and we have two different cameras. The main camera is the camera that was selected, or my default camera selected in Vue in the standalone. Only one camera will show, no matter how many cameras are available within the scene within the standalone. There are actually 3 cameras, but the one that is selected last, in this case the default scene having the main camera selected, is the one that is loaded in. Now, it's typically a good idea to use the Vue main camera because of the different multipass options and the ability to output the G buffer. And that way everything matches and you don't need to worry about any incompatibilities. This camera will also match the resolution setting. that was set within Vue. So if you go to my properties, this was the resolution I had set. I'm going to go ahead and change it. There's a possibility it will revert back, but we'll just have to see right now. Go ahead and change that over to 720p HD. And now if we take a look, there's also two lights that have been, or an additional light that's been created. The sunlight is the Vue light. And in this case, it doesn't look like it matched the other light at all. We'll have to go ahead and take a look at the two lights. So this is the original light we have. And then we also have our sunlight, which is way off on the side over here. And is pointing in an entirely different direction. So because this scene is so simple, I'm just going to be deleting the native light. And basically the LIghtwave light, go to light, minus key on the keyboard, clear it from the scene, and now just work with the Vue light, which does create or works the same way as a LIghtwave light, but also controls the way the lighting is set up in Vue. If you need to preserve your existing light, then it's a good idea to set up a different sort of conversion or match the settings, or even link the two lights together, linking their rotation. One option is pretty important to have disabled, because it doesn't have a whole lot of purpose within the integrated version of Vue. It's the point at camera option for the sunlight. So with the sunlight selected, we're going to go to the xStream menu, and we're going to edit, or we're going to go to the object properties, which is going to pull up the lighting options. And there's a point at camera. By default, it might be checked on, so it's a good idea to turn it off. Otherwise, what's going to happen is anytime you modify and move the camera, it's going to move the light as well, and we don't want those linked. We want it to be stationary. So within these options, we can adjust within the light editor some of the more advanced lighting effects, setting up volumetrics, a little bit different for the sunlight than if you had spotlights or point lights. Also setting up light gels, lens flares, and then you can set up influences as well for the specular diffuse, and then you can include or exclude objects from the lighting, set up a variable color. Right now, just looking at the defaults for the shadows, we have enable shadows automatically set to ray trace mode. Vue does have the option to use a shadow map as a ray trace or a blurred shadow map, but it is not compatible with the shadows within LIghtwave. So LIghtwave objects will not cast shadows on Vue objects if the shadow map mode is turned on. So we're just going to stick with the ray trace. The color is defined by the atmosphere, so we are going to leave that at the default white. And now we can modify the light. The rotation settings can be set directly within LIghtwave, so we can adjust the heading, change that to the desired setting. You can also go into the atmosphere editor. So we're going to go to atmosphere, atmosphere editor, and under the sun tab, we have the ability to adjust the position of the sun. The azimuth is the rotation of the sun around the scene. So if we were to take a look in the top view, the azimuth would be our heading around the scene. and then the pitch is just the pitch. So up and down, and that's going to be the green line that is showing up. I believe the green line. And these will update back and forth accordingly because the objects are linked together. There's basically the LIghtwave light, and then within Vue there's a duplicate light that is created in order to light the Vue scene. And we'll take a look at some of the other options a little bit later. So this is just using the default settings, no clouds or anything, and using the spectral model. So I'm going to go ahead and just render this out so we can see the current setting, just with the default, the ground plane, and just having this lighting set up. So we can see the castle object casting shadows onto the ground plane, and the entire scene being lit by the Vue light. And the shadows are really intense right now. So we would need to either enable radiosities, or what we can do is decrease the shadow density. We may have to do that independently between the two applications. So setting the how dark the shadow is within LIghtwave, and then also setting the density within Vue. If you want to load new atmospheres, you can just go to the atmosphere, load atmosphere, and then it's going to give you the ability to choose from the presets or any atmosphere you create yourself. So you can set up your own atmospheres, going to the atmosphere editor, and down in the lower right you can save out your current atmosphere. So any changes you make, if you want to save them out to have that atmosphere available for other scenes, you can just go to save and then load it in at any time. You can also load in atmospheres directly from this interface as well, or create a new atmosphere. So let's go ahead and add in terrain to the scene. So we can go to Object and Create. And there are two different types of terrains. A height field terrain, which is a fixed polygon terrain, and a procedural terrain, which is a dynamic subdividing terrain. So basically an infinite amount of polygons available with a procedural. So we're going to add a standard procedural terrain. I'll go ahead and switch over to the perspective view. And also change the grid size, make it a little bit easier to work with. Okay, so now we can see the terrain object, and this is what's called a proxy object. A proxy object is the representation of what is being rendered within the Vue scene. The geometry and the object itself are not going to be rendered, nor the materials. The ground plane we have is also a proxy object, and pretty much everything we're going to see within the OpenGL is just for manipulation of the primary vectors, so position, scale, and rotation. But the actual geometry itself and their materials are not going to be used for the render. So if we take a look at the procedural terrain object within the object properties, we see the Vue 7 xStream plugin added in. Now, once again, as I mentioned in the previous lesson, even if you're using version 8, it is going to say version 7 because of the compatibility. And that also has to do with basically the backwards compatibility and being able to open previous Vue scenes created in version 7. If you go to the Options panel, we also have the ability to set the core version. So you can change which version of the program or plugin is going to load, either dependent on the scene or the version the scene was saved in, or just overriding everything, forcing it to open in a specific version. So those are some pretty cool options. Okay, so going to the Render tab, we can see that it is unseen by rays, unseen by camera, and unaffected by the fog. So that way it's not going to show up in the render, and it's really just here so that we can manipulate it. So we can adjust the scale. And we can change the position. And change the rotation. And that is basically the extent of how we can modify the proxy. Any sort of deformation or anything set up to that respect, it's not going to really modify the object. It can just cause potential problems. The proxies can be used for collision objects, and also have some other possibilities you can use them for. But because of the way the scale is set up, it can sometimes cause problems with calculation. So here's a render with the terrain intersecting with the castle. I also want to note that the alpha, if we switch over from the color image to the alpha, we can see it cutting out the sky. Depending on the atmosphere and the density of the atmosphere, the overall thickness of the atmosphere is also included within this alpha. So right now there really isn't a vast density of the atmosphere in order to see that. But if we have a scene set up for that, it will be incorporated with it, which is pretty nice. So going back to the terrain object, we can, to modify and edit these objects, use the Object Edit Object command. So going to the Object panel and selecting Edit Object. In this case, since we have a terrain, it's going to open the terrain editor. Because we have a procedural terrain, and we currently don't have a sculpted 3D terrain, the pixel dimension up at the top is really only used to define one of the modifying two-dimensional layer, and not the actual procedural that's rendering. So this really isn't 256 by 256. It's really several million polygons. So you can modify and edit your terrains. In this case, we have procedurals. We can access the altitude production. I can also choose to clip out the bottom of the terrain if we don't want to have that square edge on it. Just clip it out a little and click OK. And then it'll go ahead and update the proxy object. Now the proxy object and the quality of the wireframe that's generated and the quality of the proxy is generated in relation to the position of the camera. So if I take the camera and now move it closer to the terrain, and then we select the terrain and we edit the object, click OK, it's going to refresh and generate a higher resolution proxy in relation to where the camera is. So that way we get much higher resolution and higher detail where we need it the most. Now, the quality of the preview, and you're going to see some issues with the terrain, with procedural terrains. If we go to the service editor, we're going to find the material proxy. And once again, this is just a proxy just used for reference. It is not actually rendering. So the reason for the tearing of the OpenGL is the smoothing threshold is set too low, so we can set it to 89 and turn off double-sided. Now any further changes we make to the terrain will set that proxy material back to where it was, but in the meantime it gives you a much better looking OpenGL preview. Or if you've finalized your terrain, you don't have to worry about it changing on you again. So any object we create is going to have a proxy generated for it. If we create another object, I'm going to create from plant species, so a plant and being able to choose which plant, basically. So the from species option just gives you the ability really just to pick which plant. Adding a plant after choosing a species will continually generate new plants based on that species. So if I select a maple tree, apparently rather large maple tree, we can see that showing up, and the proxy object generated for it. Now, it's not going to render this low res. This is just the representation of the 3D object. So we can also edit this object and open up the plant editor. And we can grow new plants up at the top, selecting the new plant. It's going to randomly generate, using the solid growth technology, a new plant based on this species. So basically, every single plant is going to be different. You might notice a few similarities. Most of these plants have a kind of base that they're created from, where it's a preset of a couple of different plants and then extrusions based on trunks and sizing and some additional modifications in order to create the variations. So you may notice sometimes a few similarities, but overall the settings are changed enough where you have an entirely new plant. Now you can also increase the geometry by hitting the ×2, which does not actually double the resolution. And in most cases, this is really just going to increase the quality of the trunk and the branches. It doesn't really affect the leaf polygons as much as it does the trunk, if at all, really depending on the species. But what you can do is increase the quality of the proxy by doing this. The proxy object is still far less and far lower quality than the actual object being rendered. So we can scale this down and position the object wherever we want it. Now, ecosystems display a little bit differently. And in order to add an ecosystem, we're going to use a material ecosystem. So we're going to select the terrain, go to Edit, actually go to Object. This is from my menu. Otherwise, what we can do is go, and one of the easiest ways could be to open the material summary. So if you open the material summary, it's going to give you a list of every material in the scene, with the exception that it will not show materials on ecosystem objects or objects that are loaded into an ecosystem. The only way to do that is within the standalone version. So there's two different versions of the grass. One is for the ground plane, one's for the terrain. So to avoid any confusion, it's usually a good idea to modify the name of material if you have the same one applied to different objects. So what I'm going to do is, with the terrain proxy selected, edit the object material, and this way we know which one's the terrain. And then we can call this grass terrain. So if we want to add an ecosystem, up at the top right here, we have right now one layer, now simple material. We can select ecosystem, which will add a new layer, and assign a new overall material name, just set to default, so we'll name that terrain. And it's going to duplicate the previous underlying material to create the ecosystem. So we'll go ahead and call this terrain eco. It'll also inherit any environment settings from the object below or the layer below it. In this case, it doesn't have any specific settings for altitude or slope, so it didn't carry anything over. What we can do is choose to add in rocks, which are randomly generated, just low polygon objects, plants, so choosing from the view species, and then also geometry objects, so actual meshes. I'm going to choose a plant, and let's pick the maple tree. And what we can do is populate. And it's going to give us a readout and say how many instances have been created, so how many objects have been generated. And it says 15, yet I don't actually see them at the moment. So to go back, I'm going to increase the density a little, repopulate. It might be an issue of scale. There's also the possibility that I did change that material proxy, and hopefully that is not interfering with it. So what I think I want to do is edit the object, update the proxy, and then go back, edit the object material, populate it, and just to make sure that everything is showing correctly, I'm going to go to the camera view, and I'm also going to go to the options and make sure that we are displaying enough of the instance proxies. And it does look like an incompatibility with either having one of these other objects in the scene generating the textures, because if we go to the OpenGL and change the shading mode over to multi-textured, we are going to see the billboard object showing. So now we're going to go back to the procedural terrain, making sure it's selected, edit the object material. I'm going to lower the size of the maple tree to 0.05, turn down the density, repopulate. And as of version 8.4, there is now an automatic refresh of the ecosystem display, where in previous versions you would have to close the proxy panel. So in other words, clicking OK, and then it would update. So as of version 8.4, it would automatically update. But it does look like there is a slight incompatibility with showing the ecosystems using the better shading mode. But we can see the overall display, and this can be edited going to the options, and we can set the number of instance proxies. So if we set this to 25, it's going to reduce the display and only show 25 of these billboards. Set it to 1, and it does seem to be somewhat relative because it does show more than one. But maybe that's just because it's a lower amount. So that can help manage the system in resources a little bit better. Let's go over to the camera view. And just rearrange this a little. So depending on the scale, you may need to reduce those ecosystem objects, as I just did, to 0.05. That's also one of the reasons why working with an internal unit of 0.1 is easier to work with in Vue, but harder to work with in order to match object scales. So here's just a quick render of the scene with that little ecosystem in there. Not a very complex scene. Just kind of showing some of the basic features. Now by default, the wind system is typically turned on. That is part of the atmosphere. Wind and breeze. If we go to the atmosphere editor, under Skyfog, or next to Skyfog and Haze, under wind, there's the breeze, which is a global wind on all ecosystem vegetation. And then there is the wind. Wind is a manual control, which you really don't have a lot of direct access to within xStream. It's a little bit easier to modify within the standalone. But the breeze is just the global overall wind on everything, and then the wind itself is a manual control where you can bend trees over and modify them that way. Okay, and I just want to show you, if we open up the Effects tab for volumetric, so Control F6, we'll see the volumetric plugin, which is the xStream plugin. Doesn't have any sort of modification for it, can't be edited directly through here. But you do want to note that the volumetric anti-aliasing, in order to get the best quality, does need to be turned on. For any previewing, just kind of previs or quick renders, you can turn the volumetric anti-aliasing off. So it is an entirely volumetric plugin. Everything is just rendering as a volumetric. Proxies are just there as a representation of the volumetric. And I also want to make a note about some of the images that are being created for the proxies. If we take a look at the surface editor and take a look at the maple tree, there are two surfaces, one for the bark, which is just a kind of overall color based on the texture maps or procedurals that are generating the bark, and then also the leaves material, which is an image map taken from the original material, saved to a temporary file, which has a just kind of a random name on it, where you just have a transparency map, basically a clip map of sorts, and then also the color. Now, those are automatically saved to wherever your operating system temporary directory is set to. Which means the more of these proxy objects you have in your scene, and going back to what I was talking about early in the training, where having the separate content on a different hard drive from the operating system hard drive can really improve performance. What you can do, and I'm just going to show you this for Windows, which is what I'm using, to be able to set up a separate temporary folder, because it is just going to save to whatever the temporary directory is, which is by default set to the operating system temporary directory within that hard drive. So in Windows, what you can do is right-click on My Computer, go to Properties. Under Advanced, you can go to Environment Variables, and there's Temp Setup for individual users, and then also in the list for the system. So what I did was change just the directory over. Typically, if we edit this, you'll see %, along with a local setting, %, just referencing the installation of the operating system. I just changed it over to my scratch disk, so S:, and then created a temp folder for that. And then I just duplicated the original setting, which would be C local settings temp, to my scratch disk. So that is where everything is saved to, in an Eon folder, and you'll be able to see all of the generated files where we have the images that are transferred over, also any sort of temporary scenes. It's all saved to that folder. So things can run a little more efficiently if you set that temporary folder to a designated scratch disk. It just makes reading and writing a little bit faster. And I've got a 4 hard drive RAID set up for a mirror, and also setting up a combination of disks. So there's 2 primary sets of mirrored hard drives. And accessing all of the content just goes much quicker, and any sort of resources tied to the scene. Whenever you're saving your scenes separately and not incorporating Vue scenes into the LIghtwave scene file, it's really important, and I'm going to go ahead and save an alternate version of the scene. It's very important that when you're finished working on the areas of the Vue scene, that you go to File and save the scene. Otherwise, nothing is going to get saved, because the Vue scene is working completely independently of the LIghtwave scene. But because of some of the problems that can happen with the incorporated scene and the possibility of corrupting your LIghtwave file, it is pretty important that you do keep them separate. If you find a good workflow for incorporating them, then by all means, it does save you a little bit of time, but it can have issues. Another thing, if we go back to the options panel, the infinite plane geometry size is going to change basically ground plane and any two-dimensional cloud planes, or also the sea object, the sea level object, and its size within the preview. Now they are infinite, and they will render all the way to the horizon, or whichever setting you have for the sea level. So if you go to Scene Options, you can adjust the sea level altitude, which is the start of the horizon. Typically, the ground plane will extend beyond that if it is raised up above sea level. Sea level basically sets the 0 coordinate for the Z. The infinite procedural terrain has a different size, and infinite procedural terrains are a little bit different. We'll take a look at them specifically a little bit later.